Hello, and welcome to our new episode series with Tom and Ruby, where we will be talking about not only wellness or wankery, but just outright bullshit that we see and just having a good debate about big topics in social media and in spheres that we will engage in. And today we are starting off with inflammation. And we thought a great way to kick this off is going to be talking about this seed oils and coconut oils debate because people say that seed oils are inflammatory, gluten is inflammatory, dairy is inflammatory, meats cause inflammation, artificial sweeteners, sugar. But what is inflammation anyway? And is it something that we should be doing everything we can to avoid? Is it something we need a supplement for? Is it something that we need to be dosing ourselves up on probiotics and all these other things to avoid? So let's start off this podcast defining inflammation, and is it good? Is it bad? What is inflammation?
Yeah, sure. So when we talk about inflammation, all we're talking about essentially is a mobilization of the immune system. So let's say you are outside walking and you walk past a thorn bush and you get a thorn stuck in your leg. That's going to initiate an inflammatory response. So what's going to happen is a bunch of cells in the localized area are going to start secreting various different inflammatory markers. So you might have heard of like interleukins, like interleukin 6 and interleukin 1 and all of these kinds of things. And their job is to communicate to the local area as well as to the broader body that there's something going on here. We need to set it's essentially an alarm system. And so what we need to do is we need to mobilize macrophages. So they're your white cells that hover up to the local area and eat all of the pathogens that you don't want. It might be that we start mobilizing things that increase blood flow to the local area. So that's how you get swelling. It might be that and that will also that swelling, because you get flooding of all of that, it increases the heat in the local area, which could potentially kill pathogens. So inflammation in that sense is just a very normal part of it's the immune response. Now, when we talk about inflammation as related to things in nutrition, that's where things get a little bit more complicated, because the mechanisms for a food causing inflammation get a bit more complex. We can cover that later, but the important distinction that we need to make is we've got that immune response that occurs acutely when you get an injury or something like that. And then when we talk about inflammation as a problem, this is where we're talking about chronic inflammation. So how inflammation is supposed to work in the thorn example is you get an increase in inflammation. That inflammation allows your body to mount an immune response that deals with the pathogens, that deals with the foreign object that's sticking into your leg. And then after a period of time, when the pathogens and the foreign object have been removed, that inflammation subsides and you go back to like a normal state. So inflammation increases and then it decreases, goes back to baseline. Chronic inflammation is essentially when that doesn't happen. So for whatever reason, whether it's because the thing that's causing the issue persists, or whether it's because the feedback loop that's supposed to turn inflammation off doesn't work, inflammation remains mounted. And that chronic inflammation is causally associated with various different conditions. So if we were to talk about diabetes, for example, excess body fat can, through a variety of very complex mechanisms, increase inflammation. What that inflammation can do is it can interrupt normal insulin signaling. So what can happen is that blood sugar cannot be stored as effectively in various cells. This leads to increased insulin production all the time, blah, blah, blah. We all know the mechanism by which type 2 diabetes arises. If you look at cancer, one thing that inflammation can do is it can increase cell proliferation. So you've got damaged cells because you've got a thorn stuck in them. What your body needs to do is it needs to scavenge away all of the broken cells, and it needs to produce new cells like scar tissue and all of that good stuff. And every time you create new cells, what happens is one cell duplicates its DNA and then the cell divides, and now you've got two cells with the same DNA. Every time you do that, there's a risk that DNA replication can be ineffective. And so every time you get cell proliferation, you run the risk of a copy error. That copy error can lead to the eventual downstream effects that lead to tumor growth, and that leads to cancer. The other way that inflammation affects cancer is once that tumor has started to grow, initially it's very good at like scavenging all of the nutrients and whatnot that it needs, but as it grows and grows, the supply is significantly outstripped by demand. What happens then is the presence of that tumor mounts an inflammatory response. That inflammatory response leads to blood cell proliferation in the local area, as well as the drawing in of all of these macrophages and stuff, and that leads to the interleukin response, and that increases blood flow. So what happens is the inflammation on the tumor itself increases the nutrient flow to the tumor, and because of that, inflammation can lead to cancer. So you've got these kind of two mechanisms. And so it stands to reason that inflammation in some contexts can be an interesting target for intervention, or it can be an interesting thing to think about, because from what we've said, chronic inflammation is something that largely wants to be avoided. But I think there's a lot of sleight of hand that goes on when it comes to the foods that you mentioned, where people kind of conflate chronic and acute inflammation, and that's where I think a lot of the problems arise.
Something that just brought up so many different topics in my head. The first one is, this is why sometimes if you were hearing him talk about macrophages and all that stuff, if you are in an acute inflammatory reaction, or you're going through some type of bacterial infection, inflammation, whatever, you'll find that if you get your blood test done in this period of time, your white blood cell count will be inflated because they are there and they are in higher numbers because those are the ones that are fighting off the infection, which is why a lot of the time you can't just take blood tests off at face value. They're showing you something that is underlying that can either be the result of your lifestyle, your behavior, your actions over the last few months, or acutely. And at the same time, like, I'm all for blood tests, but what's the whole point of you getting a blood test if you're not willing to actually address the root cause of the issues that you are now seeing on the blood test results? It's almost like saying, okay, I'm going to band-aid the hole in the ceiling when it's leaking water up there, but that leaking water is still going to cause damage elsewhere because you haven't actually turned off the tap or whatever it is that's causing the leak. So the band-aid approach isn't going to work. Now, as Tom was talking about, like the inflammation response and the proliferation of cells, I cannot say that word. This is where you can look at exercise as a pure example of inflammation in itself, in that exercise increases this thing called reactive oxygen species. Now, you can say that, oh, inflammation is bad. Yeah, well, in this context, one of those species is called superoxide, and it has many positive benefits in your body in that it, like, just as inflammation can cause cell death in a negative way, inflammation can also cause it in a positive way, which is exactly what exercise does. That is what you want autophagy. People talk about fasting and all this other bullshit for autophagy. Well, exercise does just that. And a big component that a lot of people are missing is that fat cells are toxic. They're not inert. They are sites. They're garbage bin disposal sites of toxins in your body. Too many of them is inflammatory. Being overweight is inflammatory in itself. Like being over fat, I should say, is inflammatory in itself. So, like, inflammation is such a broad topic that you can't just condense it down into what foods are causing inflammation, what foods are not. I don't know if now you want to veer into talking about the oils and the certain foods, but we hear a lot, seed oils are inflammatory. You'll see it everywhere. And it's kind of funny because when I was brought into the whole oil business and add oils, the oil that I got told to add to my food above all oils, even though I'm WOG, and it's olive oil for the WOGs, I actually got introduced to it through increase your flaxseed oil. Flaxseed oil. But why was I told that I should be having flaxseed oil out of all oils if seeds are inflammatory? Because it is a high source of an omega-3 called ALA, which is actually anti-inflammatory, and it's been associated with lower heart risk, lower cause mortality. And it's kind of funny that we've been told that we should be consuming coconut oil when coconut oil is actually inflammatory. It is a saturated fat, albeit the fact that it is a medium chain triglyceride. So it doesn't put the same effects into the body that and like other saturated fats do. Like butter is one of the worst saturated fats that you can consume. And I'm sure that Tom can ramp on about this, which is why I'm very on top of telling my girls as well to minimize, if not eliminate, butter from their foods. Like, of course, a little bit here and there isn't going to be detrimental, but butter in itself, I remember seeing Dr. Spencer Nadolsky, doing a self experiment in having butter every day. And his blood panel markers, they were terrible. His cholesterol went through the roof and all these other blood, like triglycerides. If you want to talk about inflammation, talk about butter, talk about saturated fats, talk about coconut oil. Seed oils aren't the culprit here. So I'll let you take over that.
Absolutely. Just to kind of loop back to what you're talking about with exercise and reactive oxygen species, I think that's a very good a very good example of the complex nature of inflammation, and why when you hear on podcasts or whatever, he says dismissively while literally on a podcast, people talk really negatively about inflammation. Well, a certain amount of inflammation is positive. So during exercise, if you're trying to build muscle, I think I said this last time, there are three primary mechanisms that lead to muscle growth after you exercise. You've got the mechanical tension, so literally just lifting weights. You've got the micro trauma that occurs within the muscle cells, which kind of dissipates once you get used to training. And then finally, you've got all of the cellular signaling, and inflammation is a big part of that. To the point that if you take anti-inflammatories after exercise, it blunts the hypertrophy response. So, yeah, whenever someone talks about inflammation as this blanket negative, just remember that every time that person that talks about inflammation as a blanket negative goes to the gym and lifts weights, they're intentionally creating inflammation, whether they know it or not. So, when it comes to seed oils and whatnot, this is where, when I was talking about the complex nature of the interaction between foods and inflammation, it really comes into the foreground, because there is a suggested mechanism by which seed oils can create inflammation. So depending on the person you ask, but generally speaking, the idea is that once you consume seed oils or omega-6 fatty acids, they can find their way into your body cells, because of course your body cells contain fat, whether we're talking about fat cells or whether we're talking about regular cells. So if you think about a cell that is in your arm, for example, that cell has a membrane. We all remember from high school biology that you see an animal cell and it's got like a membrane on the outside, kind of like an egg, and then there's a bunch of crap in the middle. Well, that membrane is called a lipid bilayer because it's made of lipids, and those lipids come from the foods that we consume. And so what happens is, if you eat a diet that's rich in omega-6 fatty acids from seed oils, you're going to get more omega-6 fatty acids in the membranes of your cells. And the suggested mechanism by which that can cause inflammation is through something called lipid peroxidation. So essentially, it means that some of those get oxidized, largely by the reactive oxygen species that we just talked about. If you've never heard of reactive oxygen species, they're often called free radicals. It's the same thing. So those free radicals can potentially bind on to these omega-6 fatty acids, and because of parts of the structure of an omega-6 fatty acid, in theory, they're easier to oxidize. That oxidization can then cause inflammation, can cause problems, and that's the suggested mechanism. But mechanisms are cheap. Always remember this. Whenever you're listening to someone talk about nutrition, mechanisms mean... Ruby, can I swear on the podcast?
Yeah.
Cool. Right. So mechanisms mean fuck all, because biology is really complex. You've got a number of different interconnected pathways and a whole bunch of redundancies. And so while it might be theoretically possible, like this makes sense. You eat more omega-6 fat, you get more omega-6 fat on your cell membranes. Omega-6 fat is easier to oxidize. Oxidized fatty acids cause inflammation. Therefore, eating seed oils causes inflammation. That makes sense. You can tie it up in a nice little bowl. Unfortunately, for people who promote this, virtually no data exists to suggest that in healthy humans, a higher consumption of omega-6 fatty acid is actually correlated with an increased amount of inflammation once other lifestyle factors are taken into account. So if you look at healthy human beings who are not babies, and that's important, the way that babies work is different. Not my area of expertise, but I'm vaguely aware of some evidence to suggest that if you give a bunch of omega-6 to like 2-month-olds, it's not good. Fair enough. I don't know about that. Not my area. Speak to a dietitian. But in healthy adults, there's no data to suggest this. In fact, there's a really good paper by Rhett and Whelan, published in I think it was 2011, 2012, that basically found that increasing people's omega-6 fatty acids by like 500%. So like a massive increase in the omega-6 fatty acids that these individuals eat did not increase markers of inflammation, which is not what we would expect if this mechanism panned out, right? And I think that's, that if you take nothing else away from this podcast, remember that mechanisms are cheap. You can find a mechanism to suggest anything. What we want is outcomes. So what we want to...
Correlation doesn't equal causation. That's the one.
Well, there's that, but there's also just more like
concept.
If you drive a car, that involves setting fire to petrol, but that doesn't mean that it's a bad thing. Just because the petrol is being set on fire doesn't mean the car's going to blow up. Like, mechanisms are one thing. What happens as an outcome is the other thing. I talk about this all the time when I talk about the gut microbiome. People talk about how important it is to eat this and this and this and this because it affects your microbiome. It's like, I don't give a shit about my microbiome. I want to know what that's going to do for my health. My job is not to look after my microbiome. My job is to ensure that the microbiome looks after me. And so I'm not bothered about changes there. I'm bothered about changes on the macro level. And it's the same thing. Even when you look at research on specifically on lipid peroxidation, people with high omega-6 fatty acid diets do not have elevated levels of the things you would expect, things like cancer, again, once you control for other variables. And this is where, if you want to talk about nutrition and inflammation, and Ruby, I'll let you jump in a second, we want to talk not about foods, but about broader dietary patterns. Because I think Alan Aragon once said it. It was like, everybody agrees that trans fatty acids are not good, that you should avoid trans fatty acids. But a Krispy Kreme every now and then is not going to kill you. And so we can't talk just about foods. We need to talk about the broad dietary pattern. And by far and away, the dietary pattern that is associated with the lowest levels of inflammation and that is associated with the lowest risk of various different kinds of disease states that will be associated with said inflammation is the Mediterranean diet. And the Mediterranean diet is rich in omega-6 fatty acids.
Yeah. And the reason why a lot of people will say that seed oils or whatever it is, omega-6s, they're inflammatory is because a lot of the people that get the out of ratio omega-6 to omega-3s because most of the food that they eat is processed, it's takeaway, it's fried foods, it's packaged foods, and they're not really the best source of omega-6 or seed oils. That is manufactured manufactured crap. Like if you're putting fresh pressed seed oils onto your food, that isn't going to cause inflammation. Now, going into this, dairy is inflammatory, gluten is inflammatory. Well, it depends for who. For some people, and fruit is inflammatory for some people because they can't tolerate fructose. Like, different people have different allowances for different sorts of food, which is pretty much the same thing that Tom just said in so what mechanism, and is this going to cause a negative response for me and who I am. Now, the funny thing with dairy is that although it's high in saturated fat, something about dairy does not have the same inflammatory response as like when I say dairy, I'm not talking about butter. I'm talking about cheeses. I'm talking about yogurts, and I'm talking about milks. Something about those particular types of dairy actually assist the fat loss process, and they don't cause inflammation to the same degree as other saturated fats. Now, maybe we can talk about that mechanism.
So, two things that you mentioned there. The first one is when you were talking about the omega, well, three things. When you were talking about the omega-6 to omega-3 ratio, the underlying sort of truth of that is there, in that, broadly speaking, a diet that is really that where the omega-6 to omega-3 ratio is out is associated with problems, but it's a misread of the data, because there are two ways that you could throw that ratio out, right? Like if you've got a 10 to 1 omega-3 to omega-6, it could be that you're eating loads of omega-6, but it could also be that you're just not getting any omega-3. And that seems to be the problem. Like we have a requirement for omega-6. We have a requirement for omega-3. And if you're not getting any, that causes problems. But it doesn't cause problems because it's in the wrong ratio. It's just because you're not getting enough. So make sure you're eating enough fatty fish. Or if you don't eat fatty fish for whatever reason, make sure you supplement them. Another thing that you mentioned was the people with a high omega-6 diet tend to have problems, but when you think about it, they're eating lots of packaged foods and stuff. That's the point that I was kind of getting at when I was looking at the broad dietary pattern, because at that point, it's like, well, okay, but is it the omega-6 then? Or is it this broad issue? It's like if I shot someone and they then had steel in their body, and I was like, oh, steel's really bad for humans. Look at this person, he's got steel in him and it's bad. It's like, no, but you shot him. Like the delivery mechanism matters. And that leads us into the dairy thing, which I think is really interesting, right? Because butter and cheese are basically the same food. But if you compare the lipid response to acute consumption of both, it's radically different. And that's because while they contain the same fatty acids, the difference is in something called the food matrix. So that's like all of the other stuff that's in the food in the specific way that it's in the food. There's a book, I want to say it's by Michael Pollan, get ages ago. I can't remember the name of it, but he, in that book, either popularized or coined the term nutritionism, which is this idea that we can look at foods as nothing other than vehicles for the nutrients within. And that's not really the way to do it, because again, if we look at the saturated fat in cheese and the saturated fat in butter, it's the same, but if you look on like the molecular level of cheese, which would be a weird thing to do with your afternoon, the proteins are still there, and those proteins are still attached to the lipids, and that seems to affect the way that it alters our lipid profile post-consumption. And so it's better to look at food. But yeah, broadly speaking, it seems to be the case that dairy foods are not as problematic as other foods are when it comes to delivering saturated fats. To my understanding, the reason for that's not wholly known. People kind of gesture towards the food matrix. It might be to do with the specific fatty acids that you find in dairy, which is more like a long chain, I believe, as opposed to other chains of fatty acids. Yeah, that we're stretching beyond what I can talk about confidently there, but to my understanding, it's not fully understood.
I was going to say, so well, if you think about yogurt in itself, that it's cheese is a curdled product of milk. It's almost like saying, okay, there's the casein portion that we just got out of milk, like the casein part of milk, and then there's the yogurt, which is the cultured yogurt's cultured. That's the word. So yogurt is a cultured part of milk. Cheese is a curdled protein of milk. Butter is the separated fat of all of that, which is why it's different. It is not really a product of milk, but the separated fat in itself. And that is why it is inflammatory. So it's a completely divergent part of the milk product in itself.
Yeah, and saturated fat consumption promotes inflammation, which is always funny to me, because it tends to be the people that talk about avoiding inflammation also advocate for high fat diets, focusing on lots of like coconut and cook your steak in butter and then it's madness. But it just indicates that people don't give a shit. They use inflammation in the same way that folks like Gwyneth Paltrow talk about toxins. It's just the nebulous bad thing that I can sell you a solution to, for the most part. I mean, even when you talk about sugar, I think
sugar. Let's go.
Yeah, so sugar's another one where it's quite interesting. You got the likes of Stephen Gundry or Gundry. He's another one of these. He's an American physician who worked in cardiovascular health, and now he recommends a low carb diet. He's one of those people. But he was the guy, to my understanding, that popularized this idea that sugar is really inflammatory. But the mechanism for that, again, sort of makes sense, but it doesn't pan out. So the mechanism that he suggests, he's one of the people that talks about how fructose is really bad. So the reason that people suggest fructose is bad is because when you consume carbohydrates, those carbohydrates leave your small intestine, they're absorbed into the bloodstream. But before the carbs hit the bloodstream, they go through something called the portal vein directly to the liver. So when you eat carbs, they hit your liver before they hit your blood. And your liver gets first pass metabolism, meaning that your liver gets to kind of pick and choose whatever the hell it wants. Now, your liver holds on to the fructose to the point that when you eat fructose, no meaningful amount of fructose ever enters into your blood. Your liver stops it. And your liver's got a few different things it can do with fructose. It can just use it for energy. It can convert some of it into glucose. And then that glucose is going to enter the blood. Or it can convert some of it into fatty acids. And what happens in like chronic overconsumption of a diet that includes large amounts of fructose is you can get non-alcoholic fatty liver disease. So your liver is getting pumped full of so much fructose that it doesn't know what to do with it. And that leads it to continually increase the amount of fatty acids that it's producing. Some of this gets stored on the liver. You get fatty liver. This can lead to cirrhosis. This can cause inflammation. And also some of those fatty acids are going to enter the blood. When fatty acids enter the blood, they leave as very low density lipoproteins. They eventually become LDL, and some of that can lead to atherosclerosis. This is the mechanism by which fructose can cause heart disease. The problem you've got is there was a sleight of hand made there, in that we are assuming that the liver can't deal with the fructose that we're putting in, and that only happens in a calorie surplus. Really, it can happen if you like artificially eat hundreds of grams of fructose a day, but you're not doing that. Nobody does. Like
Statistically, that when we're talking about fructose, you need to realize as well that fruits aren't fructose. They're a mixture of different sugars. They're fructose and glucose. Fructose and sucrose. That's the other one. So there are three different sugars to think about here. There's fructose, sucrose, and glucose. Unless you're having high fructose corn syrup, you are not ingesting pure fructose. Continue.
Even then, high fructose corn syrup isn't pure fructose. It's like 55% fructose. So the only difference between high fructose corn syrup and sucrose is that 5%. So sucrose, which is table sugar, that's 50-50 fructose and glucose. High fructose corn syrup is about 55-45 fructose and glucose. The only thing where you can get reliably like loads of fructose is agave syrup, which I want to say is like a high percentage of fructose. I think it's all fructose, something like that. Maybe maple syrup as well, but nobody eats loads of that. It's expensive. But yeah, so let's say you're not eating in a calorie surplus. Let's say you're eating at maintenance, and let's say you're relatively active because you listen to this podcast. You're probably an active person. What you're doing all the time is you are eating a bunch of carbs. Those carbs are getting stored in your body because you don't need them. And then when you exercise, your body's using them. And then in between meals, your body's using them. And over time, you stock up your glycogen stores and then you empty them a bit. If you're doing that while consuming fructose, you are going to be fine. The problem you've got is if you are inactive and consume a hypercaloric diet, then what happens is you stock up your glycogen stores, you stock up your liver glycogen, and then you keep drinking full sugar Coca-Cola. at that point, you're consuming lots and lots of fructose and placing that within a liver that's already fully stocked with glycogen because you ain't doing anything, and because you're eating plenty of carbohydrates to stock up your liver glycogen. And at that point, your liver is going to start de novo lipogenesis, and it's going to start producing these fats, and it's going to store these fats on the liver. If you're an active person, fructose is not a problem for you unless you're eating loads of it on purpose. Eventually, you will cause a problem. But if you're eating some sweeties every day and a couple of apples and a banana and you're active, you're going to be grand. I mean, there's a reason that fructose is in sports drinks. Like, it's there for a reason. It's important.
Yeah, I think this is a really good topic that we can lead into next week's as well, because next week we'll be talking about artificial sweeteners. So we can talk about, okay, so sugar or sweeteners, like what should we go for? What's the healthiest option? And then where does the sugar debate come in? But I guess to finish off the sugar concept is, instead of looking to reduce sugar intake per se, look to reduce added sugars. It's the added sugars that you want to be very skeptical of in your diet. But the thing is, it's not even the sugar itself. It's, okay, well, if you look at the research, it's not the sugar, it's the low fiber in the diet, it's the low plant foods in the diet, it's the lack of everything else that makes sugar so bad. And it's the overabundance of calories in themselves that makes sugar so bad. Because if you're in a surplus, that's when sugar can become toxic. If you're in a surplus, that's when fructose can become toxic. It's when you're lacking on fiber that sugar can cause a lot of health issues. Like, this ties up everything back to the very beginning. Okay, so what is it in the context of the diet itself versus the food? There are no good and bad foods. There's good and bad diets. And then it's like, how is it, what makes it a good or bad diet for that individual in that period of time? Because it can be a great diet for that individual maybe in 3 months from now, but for right now, it's not, they're not in the best health state to be able to withstand the diet that they're on right now, kind of thing.
Yeah. The way that I try to think about it is that everything you eat is like, it's referred to in research as an exposure. So if we're looking to determine the risk of someone's getting a certain outcome, we need to look at the totality of all of their exposures. And sugar is an exposure. Is it a positive exposure? Probably not. Does it cause problems on its own? No. So when we talk about, like, because you need to understand this to be able to understand how a nutritionist can say at the same time, sugar is not a problem, don't eat loads of sugar, because they seem conflicting, right? Let's think about the lifestyle, the entire lifestyle of a person who eats 200 grams of sugar a day. Like, that is not a person who avoids smoking, doesn't drink alcohol, is regularly exercising, is going to bed on time, is waking up on time, is eating enough fiber, is eating enough fruits and vegetables, gets enough protein. Like, that is not what they're doing. And so we can almost look at the sugar as a marker of a lifestyle that leads towards a greater risk of negative outcomes, rather than the sugar being like a poison. I think the idea of food as medicine has done loads of damage to the way that people think about food, because how medicine works is you take it and it has an acute specific effect on your health. So if you take an anti-inflammatory, you eat that anti-inflammatory, inflammation goes down. That's how that works. If you have inflammation and you eat some curly kale, which is an anti-inflammatory food, inflammation doesn't immediately go down. That's not how that, because it's not a medication, it's not a medicine, it's a food. And similarly, if you eat some cyanide, your health gets really bad really quickly. If you eat some sugar, nothing happens. But if you lead a lifestyle that is associated with a really high sugar intake, you're probably going to run into problems. And so that's the way that I would think about it. And it goes back to the trans fats are not good, but you can eat a Krispy Kreme and you're not going to die side of things. Like, I wouldn't even say, like, avoid added sugars, really. I would just say emphasize whole foods in your diet. And if you do that, you don't eat a lot of added sugars because whole foods don't have them. And eventually and that will lead you towards a dietary pattern that's promoting of health. And the elimination of sugar is not the reason it's promoting of health. It's everything else and the fact that it doesn't have lots of sugar, if that makes sense.
it's such a great way to sum up this whole podcast, in that you need to zoom out and see, okay, well, how does this relate to me in the right nows of everything? To put a tie on the anti-health and wellness Wank3ry series episode 1, I want to kind of allude to something I just came across in the whole thing of inflammation and reactive oxygen species. I found a paper that says that the combination of ALA and superoxide, which is a reactive oxygen species, actually has improved diabetic neuropathy. And there's also evidence of superoxide, reactive oxygen species, in that it reduces the inflammatory nature of arthritis in some individuals. So there's a lot of positives as well as negatives to inflammation. It's just, okay, what context are we talking in, and how does this relate to you? Any summarizing words from you?
No, I think that's a beautiful point. I think that just highlights, because that is not saying that inflammation is good. It's just a refutation of the idea that inflammation is always bad. And so to kind of go back to first principles, don't make decisions about what you're going to eat based off of inflammation. You're looking too small. We're focusing on the trees. Look to the forest. Eat a broadly healthy diet, which is primarily going to be made of unprocessed foods, lots of plants, plenty lean meat, plenty lean proteins, and you'll be fine. You don't need to worry about inflammation. And if someone tries to tell you that you need to do something because of inflammation, ask them, okay, show me the paper that indicates that doing this thing increases my risk of a certain disease. Because right now you're talking about mechanisms, and mechanisms mean fuck all.
I love that. Thank you for listening to episode 1. If you have any topics you would like us to talk about, any questions, anything at all, I am going to include a question box on the Spotify place where you can listen to this. Otherwise, reach out to either Tom or I will leave our handles in the description, as well as a little summary of episode 1, and we will catch you on the next one.